Welcome back, my dear students. Now in this class we will solve three problems. One problem I will give homework and two problems we will solve clearly. Okay. The problems are very easy. You should know the equations that in previous classes many equations we solved, and if you know them, then the problem solving becomes very easy. Just it is a plugging the known values into the equation and getting the answers. Okay, now look at this problem first. Two-dimensional stress system has a tensile stress 200 MPa. 2D stress system means what? This is your stress system. In this one, tensile stress is 200 and compressive stress is 100 MPa. Okay, very important. Compressive stress is 100 MPa. Acting on a two mutually perpendicular planes. Okay, right. This is a one plane, this is another plane. Both are mutually perpendicular planes. Shear stress of 80 MPa also acting on the element. Okay. Then determine normal stresses on the plane 30 degree. Very important. 30 degree with respect to y-axis. Shear stress on the plane 30 degree with y-axis. Resultant of normal and shear stress on above said plane and its orientation. Next, principal stresses and its orientation, maximum and minimum shear stresses and their orientation. Right. Before solving any problem, you should know some very important points before derivations I used to tell. That is if this is a general stress system, then this will be sigma x, and this will be sigma y, and this will be tau xy, and this will be interested plane, and this is the theta, right? But the conditions are sigma x should be greater than sigma y in numerically, and the second condition was sigma x should be tension so that positive. If it is compression, that is negative. Sigma y must be tension so that positive. If it is compression, that is negative. Then third one is tau xy should always meet right top corner. See, the arrows are here, they are meeting right top corner, then that is a positive. If they are meeting left top corner, then that is a negative. And for theta should be always with respect to vertical, and fifth one, theta must be always anti-clockwise measurement. Then all of the things are positive. This should be there. Now going back to the problem, here tensile stress is given, but they did not tell you whether 200 I have to consider it as a sigma x or sigma y, and this 100 I have to consider sigma x or sigma y. They did not tell, right? But the first condition is there here, no? Whichever is maximum, that is a sigma x, whichever is a minimum, that is sigma y. From this I can get a conclusion that 200 is a sigma x and this 100 is a sigma y. This I got. And shear they have told 80, but they did not mention whether it is a right top corner or left top corner. They did not mention. Therefore I will assume it is a right top corner. With all these information, if I draw the diagram, it becomes like this. This is a tensile 200 MPa. This is a compression. This is 100 MPa. This is a tensile 200 MPa. This is a compression 100 MPa. And this is a right top corner. Two arrows at right top corner. This is 80. And go back to the problems. Here the normal stress and shear stress they want on the plane 30 degree with respect to y-axis. Okay, 30 degree with respect to y-axis. But whether it is clockwise or anti-clockwise, they did not tell. Therefore, I will consider anti-clockwise only because I want positive results, right? That's all. Then I will draw an interested plane here. This is a plane of interest and this is your theta value. If you are able to write this diagram exactly, then nothing is there in this problem to solve. Here you call sigma x is 200 and sigma y is minus 100 and 2xy is 80 and theta is 30. Over. Then the first question they are asking, sigma theta equal to 30 degree they want. Then sigma x plus sigma y by 2 plus sigma x minus sigma y by 2 cos 2 theta plus 2xy sin 2 theta. Right? Here go on substituting. 200 plus of minus 100 divided by 2 plus 200 minus of minus 100 divided by 2 cos 2 into 30 plus 80 sin 2 into 30. The answer you will get 194.28. Check it, MPa. Then 2 theta sigma x minus sigma y by 2 sin 2 theta minus 2xy cos 2 theta. Then here again 200 minus of minus 100 divided by 2 into sin 2 into 30 sin 2 into 30 minus 80 cos 2 into 30. The answer you are going to get is 214.07. Okay, but the very important thing here is, go back to the question. Here they are asking third question, resultant of normal and shear stress on the above plane. Means there is a plane here, on this plane you got, this is a sigma theta, that is 194.28, and this you got shear stress, this is a 214.07. Then they want resultant will be somewhere here, this I will call it as R. Then R equation will be what? R will be equal to square root of sigma theta square plus 2 theta square, that is 194.28 square plus 214.07 square, other root, that's root. Then you will get the answer. Wow, sorry, this value is 89.90. This value is 89.90. Then this value becomes 214.07 MPa. Okay now? Over. Then go back to the question. They are asking principal stresses and their orientation, maximum and minimum shear stress and their orientation. Then the principal stress will be sigma 1 sigma 2 equal to sigma x plus sigma y by 2 plus or minus square root of sigma x minus sigma y by 2 whole square plus 2xy square. Then this will be 200 plus minus 100 divided by 2 plus or minus square root of 200 minus of minus 100 by 2 whole square plus 80 square. The answer you are going to get here is, don't know, because here plus is there and minus is there. When you use a plus you will get sigma 1, when you use a minus you will get sigma 2, then when you use a plus value then you will get a 220 MPa. 220 MPa. When you use a minus you will get a minus 120 MPa. Okay now? Then orientation you want, theta p1 equal to tan inverse or 1 by 2 tan inverse 2 tau xy divided by sigma x minus sigma y, that is your 1 by 2 tan inverse 2 into 80 divided by and 200 minus of minus 100. This answer you will get 14.04 theta P1. Then theta P2 will be equal to what? Theta P1 plus 90 degree. That answer you are going to get 104.03. Okay. Next you want tau 1 comma tau 2, that is the maximum minimum shear stress, that is equal to plus or minus square root of sigma x minus sigma y by 2 whole square plus 2xy square. And here then again substitute plus or minus square root of 200 minus of minus 100 by 2 whole square plus plus 80 square. Then here again plus is there, minus is there, therefore when you use a plus, tau 1 becomes 170, and when you use a minus, tau 2 becomes minus 170. Then theta S1 equal to theta P1 plus 45 degree. Theta P1 you already know, 14.04 plus 45, you are going to get 59.04, and theta S2 will be equal to theta S1 plus 90. That answer you are going to get 149.04. Problem solved. Once again go back and read the problem and go through the solution. This problem is over. Going to the second problem, tensile stress of 120 MPa and compressive stress of 90 MPa applied on the point of a stressed material, strained material with mutually perpendicular planes. The maximum principal stress is limited to 150. Very important. Maximum principal stress is limited to 150. Determine corresponding to shear stress on the plane. What will be the maximum shear stress on the point? What will be the maximum shear stress on the point? Very interesting question it is. Now I will just draw the diagram based on the given data, and here 120 and 90 both are given, both are normal stress, but 120 is a maximum, therefore this I will consider as sigma x and this I will consider sigma y. Then sigma x tensile, therefore positive, this is your 120, and this side it is a compression, this is a 90, this is a 90. Okay. Then shear, then is there any shear given? No, it's not given, but I have to consider. Not given, but that is unknown. That is unknown. How I say that it is unknown? Because here they said determine corresponding shear stress on the plane. On the plane you want shear stress, means this shear stress is unknown. That I want. Means sigma x I got here 120, sigma y I got here minus 90. Tau is unknown here, and theta is not given. Why theta is not given? Because they are not interested on interested plane. They are interested on maximum and minimum stresses. Here one thing it is given, maximum principal stress is given. Maximum principal stress 150. How you can write that? That is sigma 1 equal to 150. Maximum principal stress is given 150. Okay. Then you already know the equation, that is sigma 1 equal to, I will write here, sigma 1 equal to sigma x plus sigma y by 2. Here plus or minus, no plus or minus. Okay, because only 1 is there, therefore only plus, and square root of sigma x minus sigma y by 2 whole square plus 2xy square. And the known values you just substitute. 150 it is known, and this is 120 plus minus 90 by 2 plus square root of, this is the 120 minus of minus 90 by 2 whole square plus tau I don't know, that is unknown. In this equation only tau is unknown. That tau, if you wisely bring it out, then that will be 84.85 MPa. Okay, you got the answer. And then the second question, just go through the question. This you determine the corresponding shear stress on the plane. This you got. What will be the maximum shear stress on the point? Maximum shear stress means what? Tau 1 equal to plus square root of sigma x plus sigma x minus sigma y by 2 whole square plus 2xy square. Now in this equation plus square root of this, 120 minus of minus 90 by 2 whole square plus 2xy, just I calculated, that is 84.85, that is 84.85 square. If you calculate, you will get a 135 MPa as an answer. Over. The problem, once again go through the problem and go through the solution, you will get it. Going to the third problem. At a strained point, the values of normal stresses at right angles to each other planes are 80 MPa and 32 MPa. See, normal stresses, both are normal stresses. And is there anything given? Both are tensile. Very good. Here it is given. Both are tensile. Means this I will consider sigma x and this I will consider sigma y. The shear stress 32 MPa clockwise on the plane carrying 80 MPa. Very important. This statement is very important. Determine maximum and minimum normal stress and shear stress and their orientation. Okay. First we'll understand the problem. In this problem, this is 80. Understood? Because both are tension, 80 and 32. Both are tension and normal stresses. Sigma x should be more than sigma y. This I got. But look at here. The shear stress 32 MPa clockwise on the plane carrying 80 MPa. On the plane carrying 80 MPa means what? This is the plane carrying 80 MPa. This is the plane carrying 80 MPa. On this plane, shear is clockwise. Clockwise means what? This is the clockwise. But shear means one down and one up. These two makes clockwise. Therefore, here it is said down and here it is said up. When this is clockwise, then the another will be counterclockwise. Then see here, we did not get right top corner your toe value. Then this toe value is 32. Therefore, sigma x value is 80, sigma y value is 32 and toe value is minus 32. This you should not forget. This is minus 32. Why? Because in our derivation, the arrows were in the right top corner, but here it is left top corner. Therefore, minus 32. Then after that, what they want? They want sigma 1, sigma 2 and theta p1, theta p2, toe 1, toe 2, theta s1, theta s2. Just you calculate it, you will get the answers. Thank you very much.